Hello and welcome to my CoprHD building session live from Cisco Europe event. This session is all about how to install CoprHD using Lab Builder, which is a automatic toolkit to just spin off VMware Workstation VMs. So to download the required binaries, just go to https://github.com/botcars, go to the Lab Builder, and inside Lab Builder there's a wiki page. Inside the wiki page, there's some stuff about Lab Builder, all the components it has, all the other things we can do with this. So we just go to the installation section. Inside the installation section, there's a PowerShell script that we just copy and paste into a PowerShell session. So I open up PowerShell um, and just paste the text in here. At the end, it will run a command called install labbuilder.ps1, which downloads all the required packages from my GitHub and extracts them. If I don't specify a directory, it will install LabBuilder in the default C/LabBuilder 2016. If you want to have another directory, just specify it. Um, at the end, I will close the PowerShell session and create a new icon on the desktop that's called LabBuilder 2016. So just make a double click in here and it loads the LabBuilder environment. Why I'm doing it? Because I first check if there's a network available, if we can connect to the internet. The second thing is I load specific modules that I don't put into the modules directory, so I load them explicitly from a profile that we have in here to make the complete process smooth and easy. Each lab or lab environment consists of something I call virtual data center, which describes my environment. So if I get lab defaults, it won't show me any defaults because I have not set them. So I revert to the defaults file, which is the defaults.xml.example. This is a example environment that we can connect to. But before we can do so, we have to download some additional files. So we go back to our web browser and we go to solution packs. Inside the solution packs, I described how, let's say, for instance, install CoprHD works. So we have to download some masters from my master page in order to run the automated build. So the first master is the OpenSUSE master, and I'm running a default host-only network. And in order to connect to the internet, we also need a gateway. I use OpenVRT for it, so I built an OpenVRT version that does just DNS masquerading netting from the VMnet 2 to our net device, and you can also download it here. Um, so this one takes you to to my master page, and if you click on OpenVRT for Lab Builder, it goes to the simplicity share where you can download the file. Once you've downloaded the files, you can expand them with a command that's called expand lab7zip, and it's in my default download direction. The download directory is env user home user profile downloads, and there's my open VRT. I just install it, and there's also the open SUSE already downloaded that we have to use later on. While this is downloading, I open another shell so I can do some more steps with the system while we are doing it. If I copy the default XML.example to defaults XML and do I get lab defaults, it will show me the defaults configured for my environment. So every build that uses the minus defaults parameter uses this configuration. There's also something that I call set lab host key, which allows me to specify a private key combination. I could copy this one here from my putty keys, paste it in here, and when I'm connecting to virtual machines using SSH, it will use this key instead of password authentication. So I configured it in most of my machines. So if you build a Scala environment or whatever it is, it allows you to connect with this host key to the environment. So um, since my OpenVRT is already installed, I do a start VMX, OpenVRT, and it will start the OpenVRT machine. The command start VMX will start any virtual machine that you have on your machine. Per default, it will search in the path where I'm currently running it. So OpenVRT starts up, and I could also connect to my OpenVRT once it's finished with 192.168.2.4, and it will take me to the OpenVRT interface. It takes a few seconds right now because the system is still booting. In order to build, so we can see here ifconfig, and you will see Ethernet 1, which is the NAT address, and you will see also BR1, which is the bridge gateway. So if we go back into here, should be online right now. And here we go, it's up and running. So if we want to start our first virtual machine or our build of CoprHD, we just run install copprhd minus defaults, and it will start a build of copprhd using the default values. So the first thing it does, it creates a base snapshot of my OpenSUSE master. Once the snapshot is done, it creates a link clone of the machine. Once the link clone is done, it will adjust some values. It will set my VMnet connection, it will set my memory, it will set my CPU. All is done from PowerShell commandlets that I've specially built for VMware Workstation. The PowerShell commands are listed in a module called VMX Toolkit. So if I do a get command minus module VMX Toolkit, it will show me all the commands like starting VMs, adding serial ports, removing serial ports, creating snapshots, set activation preferences, set VMX processors and all that stuff. So I use the same to configure the virtual machine. Once the virtual machine is configured, I'm starting booting it up. From there, I wait until the operating system is up and running, until I can reach the operating system by using the VMware tools. So I check for VMware tools up and running. Once they are up and running, I issue some bash commands. So I have a command that's called invoke vmx bash that runs bash commands, or also runs expect fashion commands to just autofill in prompts in the remote side. So I pretty much wrap my statements that I want to run, my bash statements, into a string and pass them to that run vmx bash, and they will be executed inside the virtual machine as normal bash commands. So I'm pretty much flexible. There's also a tool that sets network connections depending on what distribution you have, OpenSUSE, Red Hat, or Ubuntu. So depending on the distribution of Linux that you use, I will use different mechanisms to set the network connections. So back to our system, I can log in here with root, and the password is PASSVORD123. The network configuration tasks on the SUSE boxes take a few moments. At the end, I restart the networking. Once this is done, I also can connect um, using, for instance, PuTTY. So I do my PuTTY to my copprhd box, and I specify the password. Right now for Lab Builder, it's password 123. If I would connect with root, root will allow me for passwordless authentication right now because I set this SSH key for my root user. So once this is done, all the tasks are started automatically inside the virtual machine. So once shared folders are enabled, shared folders allow me for exchanging files between the VM and the virtual machine. For instance, I built a external repository for the additional packages we built, so that I don't have to download packages from the SUSE repository each and every time. Um, So if I go right now into my log directory, the first thing is I clone into the Git repository. If I go to /temp, do a ls, I pretty much specify all everything that I do here with a log file. So if I do a tail -f into git clone.log, sorry, it shows me that it's cloning into copprhd controller. The next thing is I am going to install the additional repositories that we use, and I'm also installing packages from our install command. New with version 3.0 of the copprhd build process is we don't require you to install packages manually because we had some issues with people doing the wrong installation of the wrong packages, older versions, newer versions, so the build failed. We are installing right now the packages from inside the CoprHD build process. So there's an install script that does everything for you. I'm calling this install script. Um, and currently it says retrieving packages, which is okay, but actually we are not retrieving the packages because what I've done here in this environment, my default sources directory is c/sources. If I go to c/sources, a copprhd folder is done and a OpenSUSE folder is done. Inside the OpenSUSE folder is there's a zip cache file, and within the zip I cache all the packages that we are downloading, so all the packages are essentially in here, and there's no need to download the files twice. Once they are in, I'm going to reuse those files. Right now the installation is going of all the packages, so it might take a while. It's installing VirtualBox and all that other stuff, tools, because during the build process, once you're going to install to build the CoprHD packages, there are options to build like VMware virtual images or Hyper-V Hyper-V files. So that allows us to build a virtual appliance for specific any hypervisor that's sitting out there. So we can run CoprHD on Hyper-V, we can run CoprHD as an image on VMware, on KVM, so whatever you want to have. It takes a few moments to install all the packages. Once the packages are installed, we essentially start with the build process. The build process then starts to download some Cradle components, download stuff from the Apache like Cassandra, download stuff from the Play framework. We're using Play framework as a responsive design front end for CopperHD to make sure we can connect with mobile devices in the same fashion and the same experience that we can, for instance, connect with normal web browsers. So you can run CopperHD from your mobile phone and configure storage resources from your mobile phone, which is pretty cool. So the installation has finished right now. Um, there's an update of the bootloader. Now the reconfigure stuffs are run. Um, a new UDEF package is installed. So this is the last update that we have to do, and then it's done. After this, we start to install Nginx, which is our web server. So there's a special version that we currently use. So we go to the install Nginx, and it shows me how we compile the Nginx server with the special settings that we want to use for our CopperHD installation. So the live demos in my background are finished, so it's stopping a little bit with the noise right now. And right now my CopperHD build starts. So we start in the build log, and it will show me everything that's running in here. So we're checking some syntaxes. We're downloading CLI packages for storage OS. We're downloading the Cradle components. I've not offlined this one because I want to make sure that I every time get the latest version. So there's no sense in just making this offline available. So some Jenkins components from the Maven. Yeah, this download, depending on your network, takes between 5 to 10 minutes. So we leave that running in here. So bear with me. It's not too long. The overall build process right now from this network here takes 20 minutes. So the whole demonstration is just about 20 minutes to half an hour. As you can see here from my run window where I run the tasks, tells you everything that he's doing right now, building CoprHD. There's a minus verbose that outlines all the different tasks that I'm still running. So let's get back to our OpenWRT. You can log into OpenWRT with the same password I use for all the other machines, which is password 123. You can get in here and essentially you can use this to see the traffic that's going on between your wireless interfaces and between your bridge interfaces, which is the NAT gateway, Ethernet 1, and the internal interfaces. You can see the connections that we currently have active in this machine. I'm not using DHCP on this one, so DHCP is completely disabled. So just for you to use it. There are some ping utilities. Once you're inside your corporate network, you can check if you get to the outside. So just use this for connecting to the outside world. Okay. There's another set of tools that I have installed during this build that are part of Lab Builder. So one set of tools is the lab tools get command minus module lab tools. There are some nice little tools like a receiving tool for the latest Java version. So if I do a get lab Java 64, it will go to the Java page and download the latest sorry version of Java. Sorry, actually I don't know the latest version, so it's just asking it. I'm browsing the web page and I don't know how often you did an offline download of Java. I found it's pretty annoying going to the page, click on I want to download another package, I want to download the full package, and it takes a long time for me. So since I use Java each and every day and want to make sure I get the latest versions, whenever I have to use Java and you don't have it in your sources path, I'm going to download the latest version from here. There are also some other neat tools like receive lab scale.io, which goes to the EMC free and frictionless page to retrieve the latest scale.io version. Um, I'm trying to do this later on, so I'm casting later on how to install Scale.io from the Scale.io storage virtual machine. You can see here last time I ran it, we were on Java 8 patch 66. Right now Java 8 patch 73 is up. So you have to check this each and every while to get to the latest version. Let's go back to our build system. It's downloading Cassandra and some other stuff, so this might take a while to get this thing up and running. Once all components are downloaded, the actual build process takes no longer than 4 minutes, so it's pretty fast. And then our complete new environment of CoprHD is being installed. As you might have seen, we're running the CoprHD version 3.0. There are lots of changes right now ongoing. You get the CoprHD changes from the CoprHD page, so make sure go to copprhd.github.io. It tells you everything about the platform, how you can participate. There are some getting started guides. Essentially, those are the ones I follow and I automate here in this test page. There's also a roadmap. So from the roadmap, you can see what new things we are bringing in. There's a timeline um, that we follow for each and every release. So we're bringing data migrations, SRDF base, we're bringing in a KVM controller, support for SRDF with vPlex. And for the next release, which is the Joda release, we will have block services for OpenStack. This is something that's done by Intel, and the file services are led by the Oregon State University. So there's a good interaction in that open source community to get the latest and greatest features in. So I am pretty keen to see Joda release with OpenStack integration. That's something I'm definitely waiting for. So we're still in the download path, so bear with me. This takes a while right now here from Cisco because everybody right now locked into the Wi-Fi. Um, the social media, tweeting, all that stuff is pretty heavy here right now, so I would name this the social event, Cisco Live 2016. So now we are compiling, and once compiling is done, and we have the final RPM, I will just install the RPM. The only thing that we need to do is a reboot then, because we also installed a new kernel. We have to bring up the storage OS, and this is exactly be done after a reboot of the system. Going back to going back to CoprHD, if I go to my sources directory, there's a CoprHD OVFN properties. So I open this one up for you just for a few seconds to see what's in there. There are connections to be set, like IPv6 address, IP address. I pre-populate them based on your network settings that you have from the outside. So my CopperHD defaults to whatever network you're on, .245, and I specify the .245. If you want to have another IP address, give it as an option into my CopperHD installer, and I will set it automatically. Once the system boots for the first time, CopperHD gets started with those values. So from a CopperHD perspective, this is the one that generates your network configuration each and every time. So we are right now into the Play framework. Play framework is our responsive user interface design that we use to enable you to run that stuff from even your mobile phone, from any browser, from any mobile phone that you want to have. And I pretty much love that one. It's fast, it's neat, and it gives you all like performance statistic and all that stuff. So from a user endpoint perspective, this is a pretty robust interface. So the portal gets assembled right now. Once everything is built, we pack it together into an RPM, and I will install that RPM on this box. Um, we're using Java 8 right now, so we moved to Java 8. If you're on an older build version that was running Java 7, the new build version requires Java 8. So in my deployment, I default to Java 8. If you want to use another repository, or if you want to use another branch, so you can select branches, you can go back to the 2.4, 2.41 branch. I will use the old installer method, which also can install an older version of this. So this is pretty much waiting, drinking coffee. You can browse into the FAQs um, on our Confluence Atlassian. There are some troubleshooting articles if something's not working. There are some tools that you can see, like project management, the Jira, we're using Atlassian for it. There's a developer wiki. We have an online hip chat if you go into any problems. There's a general group on Google Groups where you can post your questions and answers. If you are not a developer, use the CoprHD user support forum. If you are a developer and you want to contribute, just use the CoprHD dev support forum. So right now we're packing together the RPM file. So build was successful. Um, takes a few moments. Once the build is done, I'm installing the RPM. You can reboot the machine, wait for just about 5 minutes, and after 5 minutes, CopperHD will be up and running, and you can connect to it from your web browser. If you want to distribute the RPM file to others, there are multiple options. You can just give them the RPM file. There's its instruction on our CopperHD GitHub page, how to make the operating system ready for CopperHD, which packets need to be installed. You also have the option to just install or use a virtual image, a VMware image, a KVM image, or a, um, a Hyper-V image. There's also Also a description on how to run CoprHD in a container environment. So if you want to run it on Docker, you're free to do so. So the RPM has been built. I'm installing the RPM right now, and we are done. So once we are done, I go just to my to my putty session in here, and I do sudo shutdown -r now. He will ask me for the password. At this point, the password is already changed me because we are changing the password. We're changing the system password to default value in order to ensure that people change the passwords. Also, the login password is changed me. If you ever ask for passwords and default passwords I use in Lab Builder, just go to the Show or Hide console view. There's a description window, which I call annotations, that I fill in. We have here the build date. We started the build at 11:36 of that virtual machine. Right now it's 11:56, so it took like 20 minutes to build CoprHD from scratch. So if we compare the time, 11:75 right now, 20 minutes from firing up, compiling, booting CoprHD for the first time. It's just a 20 minutes progress. Um, Right now, CoprHD is reading the OVFN properties file, populates that values. So on ESX environment, those are pushed by vSphere. So you will set your IP addresses from within vSphere. Then the system is up and running. And we can side in with the CoprHD user or with the Lab Builder user. I'm trying CoprHD, CoprHD. Hope I spelled it right. I'm using Lab Builder. Builder PASSVORD 123. Yeah, that was right. If I do a if config or a su minus and the password is change me, I'm in the root shell. I've config will show me the IP configuration of the system and do a system control status storage OS. My systems are up and running. Um, It's booting storage OS right now, so we can go to our web browser and go to 192.168. We can go to the page. Eventually, this page hasn't been completely deployed, so if the portal is not up and running like this, it will auto reconnect in a while and get me to the page. I put it to this side. So the PowerShell right now says it's done with the build. It tells you user ID password we have to use for the first login, which is root and change me. There's the user for the lab builder, which is lab builder password 123. Just use su or sudo commands, like I explained earlier. Later on, we will use install scalio storage virtual machine script, which automatically downloads and install scalio. So the installed scalio storage virtual machine, while this is running, is pretty simple. I specify minus defaults here and minus configure. Um, So since it does not have any Scala.io master found, I have to use the minus import to get the latest version. So CoprHD is up and running right now. I specify root and change me, which takes me to the password change dialog box. and type in PASSVORD123, PASSVORD123, and then we type in the network settings and the DNS service 192.168.2.4, and I use the same for NTP, and we can click the finish button. Once the network is configured, it will go to the general overview page, shows me the licensing state, the version that I currently installed. It's CoprHD controller trial version, open source 3.0 version. We could also go to the health dashboard and the housekeeping status. So we go to my Viper controller, it's called Viper 1 in here, and shows me all the performance dashboard. Memory is currently at 74%. All services are up and running. You see the IOs that are currently pushing down to the disk. So if I click on services, I see all the services that are up and running in my system. Total of 10 services. You see the port services up and running. They started 4 minutes ago. The authentication service, GUSVC. So you can see here that all of my servers are running and how much virtual memory they are consuming. So that's it from my side. I hope you enjoyed the session and tune in for the next one. We are going to install the Scale.io storage virtual